The overall goal of this procedure is to determine the embedded sensitivity functions of a structure. The procedure will be demonstrated on a residential scale wind turbine blade.
This method can help answer key questions related to structural health monitoring, such as how a structure's response will change due to damage at a certain location. The main advantage of this technique is that it provides a method for modeling a structure based on experimentally measured data, eliminating the need for knowing specific parameters for mass, stiffness, and damping.
Begin with designing a test fixture to replicate realistic boundary conditions. In this example, bolt locations are prepared to match the mounting locations of the blade. Fabricate the fixture from steel to minimize the fixture's contribution to the dynamic response of the test specimen. Assemble the fixture by first bolting the blade to the custom T-bracket and then clamping the fixture to a steel table. Now, identify and mark a grid of impact locations on the blade. Use a marker or wax pen to mark and number 30 points that span the entire blade. Then, measure out the point's relative position to use for the visual representation of the test results. Next, prepare single-axis 10 mV per G accelerometers.
Choosing the proper sensitivity of your accelerometer is critical in getting good signal-to-noise ratios. Also, be sure that the frequency range of the accelerometer is sufficient to capture the frequency range of interest of your specimen.